So this symbol is universal quantifier. Universal quantifier. And this symbol is what? There exists means it is existential quantifier. Existential quantifier. So when we want to mean that there exists something, okay, there exists some epsilon, there exists some delta, okay, we use this. There exists. That is why this is called existential quantifier. Okay? So it gives us the existence of something. And universal quantifier, it is used in cases where we want to say that something is true for all, for everything in that domain. Okay. So suppose something like x squared is greater than or equal to 0 for all x inside R. So this is given using universal quantifier. X squared greater than or equal to 0 for all x inside R. What does it mean? Given any x, so it is given any x inside real numbers, this is always true. X squared is greater than or equal to 0. So suppose this is one. Another example is say there exists an x inside the set of natural number such that 3x equal to 21. Okay. So this is an example using existential quantifier. Okay. There is some natural number which satisfies this. Okay. So if I write something like 3x minus 21 equal to 0 for all x inside natural number. So this is written using universal quantifier, but this statement is false. Okay. 3x minus 21 is 0 for all x in natural number. This is not true. Why it is not true? Again, 3x minus 21 is 0 for all x inside natural number. This is false. Why? Why this is false? How to justify this is false? কিভাবে জাস্টিফাই করব this is false? How to justify? Means we will try to find out an x for which this is false. So that is how we justify. This example several times I told you. Suppose this is one triangle, this is another triangle. Okay, this is another triangle. Okay, this is something. Okay. So if I say that every figure in this board is a triangle, that is false. Why it is false? Because there is a figure here which is not a triangle. So here I am saying that every natural number satisfies this. So, but this is false. Why it is false? Because there is some natural number which doesn't satisfy this. Okay? ওই বেসিক জিনিসটা হলো গিয়া মোস্ট ইম্পর্টেন্ট পার্ট অফ ম্যাথমেটিক্স। এই জিনিসটা যদি বুঝো না তাহলে এটা কিছু বুঝতে হয় না। এপসাইলন ডেল্টা এটা সব মাথার উপরে দিয়ে বাউন্সার হয়ে যায়। শুনে একদম সিম্পল লজিক্যাল কনসেপ্ট। Every natural number satisfies this. Okay, suppose I say every player in Indian cricket team can bat like Virat Kohli. It is true or false? False. How to justify it is false? Pick up one player who cannot play sixes. Hey. Chahal. No concept like every player can play very nicely. So this is false. No, there is that is the concept. Just common sense. This is just common sense. Okay. If I say suppose every student here has scored 100% in maths. So in immediately you will say, no sir, I'm to form by there is some student who has not got this, okay, 100%. So it's a very, it's a thing of common sense, just common sense, okay. Normally আমরা যেভাবে conversation করি, okay, immediately we can say that now this is false. So to justify that something is false, you have to find out. To justify something is false, you have to find some example where this particular thing is false. Okay, that is the concept. So, okay, so if I say something like this, for every x in z, okay, the set of integers, for every x in z, there exists y in z such that x plus y equal to 0. So this is one statement, okay. For every integer, there is an integer y which satisfies x plus y equal to 0. Okay. So this is true or false? For every integer, there is another integer which satisfies x plus y equal to 0. This is true. Okay. Because if you take y as minus x is also an integer. Okay, so this statement is true. So suppose I want to find out the negation of this. What is the negation of this statement? You try. Negation will be for every integer this is satisfying. Negation is there is an integer which doesn't satisfy this. For every integer this is satisfied. So negation will be there exists an integer which doesn't satisfy this. Doesn't satisfy this money. This says that there is an integer such that this happens. So its negation will be for every y in z, this doesn't happen. No. For every y in z, what happens? X plus y is not equal to 0. This is the negation of this statement. Okay. For every integer, there is an integer y which satisfies x plus y is 0. Its negation is there exists an integer such that for all y in z, x plus y is not equal to 0. Okay. This is the thing. Similarly, you try another one. Say for every epsilon greater than 0, there exists a delta greater than 0 such that say such that epsilon plus delta is less than 2. Okay, suppose this is your statement. For every epsilon greater than 0, there is a delta such that epsilon plus delta is less than 2. Okay, so you try to write the negation. Okay, try to write the negation. You have to see. You have to understand this. Otherwise, you will discuss for your last. For every epsilon, there is a delta which satisfies this. Okay, you write the negation. What is the negation of this statement? Okay, I don't know whether this is true or false. No matter. One of them will be true, another one will be false. Try. Always remember the negation of there for all will be there exists. Negation of there exists will be for all. Okay. For everything. With the opposite of negation of strictly less than is what? Greater than or equal to? Greater than or equal to is what? There exists an epsilon greater than 0 such that for all that delta greater than 0 এখানে such that লাগতো না for all delta greater than 0 epsilon comma bracket epsilon plus delta greater than or equal to. Okay. There exists a for all delta there exists greater than 0 for all delta greater than 0. For all delta greater than 0 this is satisfied. Okay. So that's the right with like so next system greater than or less than or that are naive which are negation equal to the apply not equal greater than or less than or equal. There exists an epsilon greater than 0 such that negation. So there exists an epsilon greater than 0 for all delta less than for all delta greater than 0 delta is a positive number. This is true. There is a delta. For all delta, delta greater than 0. So that is the now step by step let us go to this. You don't know about doctor? चलो तो नहीं. तो सभी तो जो हमारे बाइक है. तो इधर किधर हो? এখন এটা ট্রাই করতে হবে all epsilon greater than 0 there exists a delta such that mod of fx minus l is less than epsilon. Okay, suppose this I am not including that part now. Okay, forget about this. So for every epsilon there is a delta such that mod of fx minus l less than epsilon. Okay, so what is the negation? There is an epsilon such that again this is for all delta greater than 0. This is not true. Fx minus l is what? Greater than or equal to epsilon. So same concept. For every epsilon there is a delta for which this is less than epsilon. Here negation will be there is an epsilon such that for all delta greater than 0 this quantity is greater than or equal to epsilon. Okay, clear? Clear isn't it? Sure. So now let us make it much more closer to this. Okay, there exists a delta greater than 0 such that fx minus l is less than epsilon whenever 0 less than mod of x minus c less than delta. Okay, let us try writing this. So in the SEC video, if you have seen that carefully, I had mentioned something about implication. Okay. What is an implication? A statement of the type P implies Q. P implies Q, or sometimes it is written as this. Okay, so we will use this symbol. P implies Q. Okay. So this is a mathematical statement. This is another mathematical statement. Okay. What does this mean? If P happens, then Q happens. Okay, that is the thing. If P, then Q. Okay. So this statement is false only under one condition. This statement is false when the this is called the hypothesis. This is called the conclusion. Okay, this is the hypothesis, and this is the conclusion. Okay, so this implication is false when the hypothesis is true but the conclusion is false. Okay, P is true into Q is false. So the implication itself is false. Okay, so I had given one example also. Say if you score something like this, if you score more than 80%, then I will give you a cycle. Okay, this was the example. If you score more than 80%, then I will give you a cycle. Okay, suppose this is my promise. Okay, if you score more than 80%, then I will give you a cycle. Under what condition you can say that I have not kept my promise? Under what condition can you say that I have not kept my promise? Okay, so my promise is a type of implication. Okay, what is the promise that I made? Promise is you score more than 80%, and this will imply that I give you cycle. Okay, So under what condition can you say that I have not kept my word? Normally,
You didn't give a
Huh?
when you are
huh?
when you won't give a cycle.
When I don't give a cycle, means when only this is false or what? তুমি যদি less than 80% পাও তাহলে তো আমি সাইকেল দিতাম না। You cannot say I have not kept my word. My word was if you score more than 80% then I'll give you this. Okay. So under what condition can you say that I have not kept my promise?
When we got more than 80% by grade.
When you get more than 80%, but even then I did not give you cycle. Okay. So this is also another common sense. This implication is false only in one condition. That you are scoring more than 80%, but even then you did not get cycle. Okay, then you can charge me that no, your promise was false. Okay, otherwise you cannot charge. Suppose you suppose I don't give you bicycle, I don't give you you don't score 80%. Both are false, even though the implication is true. Okay, so this is also false, this is also false, but I cannot say that the implication is false. Implication is true. Okay, my promise is true. So something like neta mandrira koine politicians ra, if I come to power I will do this. Okay, so you can charge him only when he comes to power but doesn't do this. Okay, but if he doesn't come to power you cannot charge him that he mitha kotha hoyse mitha eto chance hoyse our chance hoyse aile na porte. Okay, so the implication is true. The implication is false in only one condition. The first one is true, second one is false. Okay, in every other cases this is always true. Okay, so I had given you this also, the truth table for implication. What was that? So this is suppose false false, false true, true false, and true true. Okay, so this implication is false in only one case, when the hypothesis is true but the conclusion is false. Okay, in every other case it is true. Okay, so it may happen that you don't score more than 80%, but I give you a cycle. Even then, this is true. Okay, so you cannot say that the implication is false when both the statements are also false. Okay, so it is something like 3 is less than 2 implies 1 is greater than 4. This implication is also true. Okay, even though it doesn't make any sense. 3 is less than 2. Okay, this is false. This is also false. Okay, so but this implication is true. Okay, a implication is true. Right, these are backward statements. So this is false in only one condition. Right. So so here for every epsilon greater than 0 there is a delta which satisfies this, such that this can be written as an implication. Okay. Such that 0 less than mod of x minus c less than delta implies mod of fx minus l is limit of f at c is L if for every epsilon greater than 0 there is a delta such that whenever this happens this also happens. Okay, and we can write this as an implication. Okay, so how will you write it in symbols? Okay, using quantifiers. For every epsilon greater than 0 there is a delta greater than 0 such that this is true. 0 less than mod of x minus c less than delta implies mod of x minus fx minus l is less than epsilon. Okay, so this is your the limit of a function is l if this happens. Okay, so under what condition I can say limit is not l? So it will be there exists epsilon greater than 0 such that for every delta greater than 0 this is false. Okay, this is false. Okay, so under what condition this is false? This implication is false if the hypothesis is true, but the conclusion is false. Okay. So, what you will write? So, for every delta, this part is true, but this is false. Okay. Whenever here was there, A is the domain of the function. Okay. X belongs to A, and there exists delta such that X belongs to A, and this mod of X minus C less than delta implies this. Okay. So for every delta, this condition is false. Okay. So what should be true? Every X inside this satisfies this. Okay. Every X inside this which satisfies this also satisfies this. So what will be the negation? Chinta karo. Okay, let me just Ajay, there exists a delta such that every X in A which satisfies this also satisfies this. Okay. So the negation will be for all delta greater than 0.
X belongs to A.
Ajay, there is an X in A which satisfies this but doesn't satisfy this. Okay. Hypothesis is true, but the conclusion is false. Okay. So for every delta greater than 0, there is, so here it was given any X in A and which satisfies this. Okay. Given any X in A with 0 less than mod of X minus C less than delta, this will imply that mod of Fx minus C is less than epsilon. Okay. So its negation will be for given any delta greater than 0, there is an X inside A with 0 less than mod of X minus C less than delta. Okay, but okay, there is an X which satisfies this but doesn't satisfy that. So, but mod of Fx minus L is greater than or equal to epsilon. Okay, so this is your negation. Okay, so a function f, the limit of a function f at C is not equal to L means what? This is happening. Okay, there is an epsilon such that no delta satisfies that condition. Clear? Limit of f is L if every epsilon, for every epsilon there is a delta which satisfies this. It is not L if there is an epsilon such that every delta greater than 0, for every delta greater than 0, this particular thing is false. Okay. So it is false means there is an X which satisfies this but doesn't satisfy this. Okay. Clear? So under that condition you can say the limit is not L. Okay, so let us write that part. So how will you write this? How will you write it? So note that limit x tends to C fx is not equal to L if there existed epsilon greater than 0 such that for every delta greater than 0, such that for every delta greater than 0, there exists x inside A, where f is a function from A to R. F is a function from A to R. Right? So this limit is not equal to L if there exists an epsilon greater than 0, such that for every delta greater than 0, there is an x inside A satisfying 0 less than mod of X minus C less than delta, but mod of Fx minus L is greater than or equal to. Okay. So this is what is happening. Fx limit of this is not equal to L if this happens. Okay. There is an epsilon greater than 0 such that for every delta greater than 0 there is an X satisfying this but not satisfying this. Okay. মানে ওই C এর আশেপাশের মধ্যে x টা আছে but it doesn't satisfy this. Okay. Existence of limit means you should be able to find a neighborhood around C where this quantity is always less than epsilon. Okay. So the limit is not equal to L means what? You have found out means whatever neighborhood you take, there will be at least one point which doesn't satisfy this. Okay. So limit is L means there is a neighborhood around C in which mod of fx minus L is less than epsilon. Okay. So limit is not equal to L means for every neighborhood around C there is some point which doesn't satisfy this. Okay. Just it is the negation. Okay. Nothing else. But you have to understand this very nicely. Limit is L means you can find a neighborhood such that mod of fx minus L is less than epsilon for every x inside this neighborhood. Okay. So limit is not equal to L means whatever neighborhood you take, you will get some x which doesn't satisfy. Mod of fx minus L is greater than or equal to. Okay. For every neighborhood, you should be able to find out some x which doesn't satisfy this. Okay. This is the thing. Here. Okay, so with this knowledge, let us go to this part. Sequential criterion for existence of a limit. Sequential criterion. Sequential criterion for limits. Or the sequential definition. So this is a theorem. Let f be a function from a to r, and let C be a limit point. Then the following are equivalent. Number one is limit of x tends to C of x is equal to L, okay, or say small l. And number two, for every sequence sent in A with xn not equal to C for all n, with xn not equal to C for all n, converging to C, okay, comma the sequence f of xn converges in R, converges to okay. So this is the sequential criterion for limits. Okay. Okay, limit of fx as x tends to C is L. This is equivalent to saying that for every sequence xn in A with xn not equal to C for all n converging to C. Okay, for every sequence xn in A which converges to C, the sequence f of xn in R converges to L. Okay, f of x center L a converges. Okay, whatever sequence you take, for every sequence it will be true. Okay, so this is an equivalent definition of limit. Okay, right? Limit is this implies this, one implies two, and two implies one. Okay, the other way also it is true. Okay, so one implies two, two implies one. Okay. So how will you show this? Whatever sequence you take in A which converges to C, the sequence f of xn should converge to L. Okay. So for example, let me just remind you. Say suppose limit x tends to 1 of twice x plus 1 equal to what? Limit x tends to 1 of twice x plus 1 is what? 3. Okay. Now you take a sequence xn which converges to 1. Take a sequence xn which converges to 1. Any sequence which converges to 1. Say other than the constant. Okay. Other than the constant. So what is that? Say xn equal to 1 plus 1 by n. This is a sequence which converges to 1. One has a sequence. xn is a sequence. This 1 plus 1 by n is a sequence which converges to 1. Okay. You take limit n tends to infinity, you will get this as 1. Okay. So if you put it there, f of xn f of xn will be 2 into 1 plus 1 by n plus 1. Okay. So what is that? It is 3 plus 2 by n. Okay. So this also tends to what? Or converges to what? Converges to 3. Okay. 3 plus 2 by n. This sequence also converges to 3. Okay. So whatever sequence you take which converges to 1, f of xn will always converge to the limit. Okay. That is the equivalent rectangle. Okay. For every sequence in A converging to C, fxn converges to L. Okay. Clear? এখন convergence of sequence টা মনে আছে নাকি? If I say that a sequence xn converges to say C, what does it mean? A sequence xn converges to C. What does it mean in terms of epsilon? Try writing. লেখার চেষ্টা করো দেখি মনে আছে ওই আইডিয়াগুলো লাগবে না এগুলো পোস্ট করে গেল হ্যাঁ দিলো ফুল ক্লাস আমি তো কইতাম ফুল ক্লাসে ফুল ক্লাসে বল তুমি সারে হয়ে গেছে মানে এর ভিতরে ঢুকে আছে সব গ্রিক পড়ে গেছে সাইড ডেল্টা এগুলো তো জীবনে তো কথাই গেছে Now try one of them. Under what conditions xn converges to C? Definition. You don't know. Properly written. A sequence xn converges to C if what? That is what you mod of mod of you have to mod of proper definition. A sequence xn converges to C if what? If for every epsilon there exists an n naught or n inside natural number. Okay, like that you have to write. All these are very important part of analysis. A sequence xn converges to C if for every epsilon greater than 0 there exists a n belongs to n or say n naught belongs to natural number such that mod of xn minus c, this is less than epsilon, or all what? কোন সময় converges to C মানে যত তোমার terms বাড়তে থাকবো it will go close to C. Okay, that is the thing. So such that mod of xn minus C is less than epsilon for all n greater than or equal to for all n greater than or equal to n. Okay, clear? A sequence xn converges to C if for every epsilon greater than 0 there exists a natural number. Okay, such that ওই টার্মের পরে there exists a natural number means what? After this term everything satisfies this. Okay, after this n naught term every other term satisfies this. Okay, n naught term এর পরে যত টার্ম আছে every term will satisfy this. Okay, that is the clear. So this is the definition of a convergent sequence. Okay, so we will have to use this. Can I use it? Okay, so how to show that these two statements are equivalent? Okay, let us try. So we have to show that these two are equivalent. Say one. The proof is something like this. First we will show that 1 implies 2. Okay, 1 implies 2. That means if the limit is this, then this is satisfied. Okay. So what is that? So let limit x tends to C fx equal to L. Let this be equal to L. Okay. Then I have to show that every sequence xn in A which converges to C satisfies this. Okay. So what is the meaning of this term? What is the meaning of this term? So first let us start with let this is equal to L and let xn be a sequence in A such that which converges to C. Let xn be a sequence in A. In A মানে every term of this sequence is inside the domain of this function. Okay. The functional domain was A. Okay. So xn is a sequence in A which converges to C. Okay, which converges to C and none of the terms of this sequence is equal to C. Xn is not equal to C for all and in because it may happen that the function itself is not defined at C. Okay, in that case we cannot write f of xn. Xn be a sequence in A which converges to C and xn is not equal to C for all and inside naturally. Okay. So if this one is 1, so by 1 or let epsilon greater than 0 be given. Or what I have to show? To show that again f of xn converges to the sequence f of xn converges to L. Okay, this is what I have to show that the sequence f of xn converges to L. Right. So that means ultimately I have to show something like this. Mod of f of xn minus L. This is less than epsilon for all n greater than or equal to some n naught. Okay, this is what I have to show. Okay. This জিনিসটা আমার দেখাই দিলাম। So let us keep it somewhere else. What I want to show this mod of f of xn minus L. This is less than epsilon for all n greater than or equal to some n. Okay. Okay. So we have to start with this epsilon. Let epsilon greater than 0 be given. Then by 1. So what does 1 say? 1 says that the limit is L. By 1, there exists a delta greater than 0 such that mod of fx minus L, this is less than epsilon, for all x inside A with 0 less than mod of x minus C, sorry, for all x in A with 0 less than mod of x minus C less than delta. This is satisfied. Okay, this is the definition of limit. Sure. This is just the definition of limit. Let epsilon greater than 0 be given, then by 1. By 1 means 1 is this. Limit of fx is L. Okay.